Yesterday we started going through and reviewing some of our exponent rules, and we also went from exponential to radical form and back and forth. So now we're going to start looking at more Math 2 level problems with those. These are often going to deal with rational exponents, which is just a fancy word for fraction. So it just means we're going to deal with a fractional exponent. We also talked about I talked a little bit about how sometimes some of them are going to be easier to solve using radical form, and some of them are going to be a little easier using exponential form. So we'll look at a couple examples when one would be easier as a radical and one would be easier as an exponential. The general rule, though, is if you don't have negative exponents and you don't have fractions inside your parentheses, honestly, it's probably easier just to solve it as a radical. So we'll start off with some smaller examples. So let's say I had 12 x to the third, y to the fourth. We're going to raise that to a 1/2. And we're going to look at a 16, say x to the second, y to the third, to the 1/3. Alright, these are both examples of ones that would actually be easier if we write it as a radical. Being we don't have any negative exponents anywhere, and the other part is there's no fractions inside my parentheses, which we'll look at one in a little while where you'll see an example like that. Alright, so what we looked at yesterday was we can go from radical to exponential, and having this fractional exponent means that I'm dealing with a radical. So I can change this into a radical. Remember, this bottom number of my fraction is my index, so it means I'm dealing with a square root. This one has an exponent of 1. So basically what that means is you're multiplying each exponent by 1, which when you multiply something by 1, it doesn't change anything. So since we have an exponent of 1/2, I knew I'm dealing with a square root. And since it's an exponent of 1, I could just keep exactly what's inside my parentheses, keep it exactly the same, and just put it underneath a radical. So again, that exponent of 1/2 just means I'm dealing with a square root, and everything inside the parentheses can just go underneath the radical. Then from there we can break them down like we did a couple weeks ago. So since I'm dealing with a square root, I need pairs to pull numbers or variables out. So I find two numbers that multiply to 12. So let's say 4 and 3, 2 and 2. X to the third means I'm dealing with 3 x's, and y to the fourth means I'm dealing with 4 y's. Again, I need pairs to pull numbers out, so I can pull out a 2, I can pull out an x, and I can pull out 2 pairs of y's, so that becomes a y squared. And leftovers stay underneath the radical. So I have an extra 3, and I have an extra x. So that would be my final answer to it. You could write that last part in that square root of 3x. You could write that as fractional exponents, but honestly in Math 2 they'll leave them as a radical. Alright, so let's try the second one. This one has an exponent of 1/3, so again it's a fraction, so it means I'm dealing with a radical. And the bottom number is a 3, so I'm dealing with a cube root. Again, the top number is a 1, so I can just stick everything inside my parentheses right underneath my radical. Alright, so now we can go through and start breaking these down a little bit. 16 can break down, let's say, into 4 and 4, 2 and 2, 2 and 2. I got x squared, which means I'm dealing with 2 x's, and I have 3 y's. Well, since my index is 3, I need groups of 3 to pull number or variable out. I do have 3 2's, so I can pull out a 2. I don't have enough x's, but I do have enough y's. Now, where you need to be careful with cube roots especially is, remember, if a radical does not have an index, it's assumed to be a 2. So if I don't write an index in this problem, it's technically wrong, because it is a cube root. I do have to put the 3 as the index. I have a leftover 2, and I have 2 extra x's. So that would be a simplified. So those are very basic rational exponents that honestly are a little bit easier just to solve as a radical. Alright, so we'll look at a couple where the top number is not a 1 and kind of see how that affects things. So if you need anything from the screen, go ahead and get it because I'm going to clear it off. Alright, so let's say I have something like 2x squared y to the 5th to the 2/3. And we'll look at 4x squared y to the 3rd again to the 2/3. They like 2/3 in math too, it happens a lot. Okay, so again, since I have a fractional exponent, it's going to be a radical. Bottom number's a 3, so that's an index of 3. Now, what's going to change about this one is this top number being something other than 1. Remember, what that means, that top number is the exponent. So that 2 is going to have to multiply to each of my exponents that's underneath here. And don't forget that 2, since it doesn't have a visual exponent, it's just like having a 1. So when I put these underneath my radical, it's not just going to be 2x squared y to the 5th. I have to apply that exponent of 2. So that's going to be a 2 to the 2nd, an x to the 4th, and a y to the 10th. Which then at that point, and I could have gone right to this step, but I wanted you to have it for your notes. 2 squared is 4, x to the 4th, y to the 10th. And then again, we break anything down we can. 4 will break down to 2 and 2, but I'm not going to have a group of 3, so I know my 4 is not going to break down. My x to the 4th means I'm dealing with 4 x's, and y to the 10th means I'm dealing with 2, 3, that's 8. I cannot count, so there's 10. Alright, so it's a cube root, so I need groups of 3. I do have 3 x's, so I can pull out an x. I'll make it look like an x. And I have 1, 2, 3 groups of y's, so that's y to the 3rd. And underneath here, underneath this cube root, I do have 1 extra x and 1 extra y. So that's a simplified, oh, I forgot the 4. Never fails. I always forget something. 4, there we go, and an extra x and an extra y. So that would be our simplified radical form for this one. So really the only difference is as soon as you see that fractional exponent, I know I'm dealing with a radical. If the top number is something other than 1, I do have to multiply that to each of the exponents before I start simplifying. Alright, so we're going to do the same thing with this second one. Again, I see a fractional exponent. I know I'm dealing with a radical. There's no negatives in this problem. There's no fractions inside my parentheses. Bottom number is a 3, so it's an index of 3. And my exponent is a 2, so I got to apply an exponent of 2 to everything. So that becomes y to the 2nd. And with my x's, that becomes an x to the 4th. And it'll become a y to the 6th. And then again, I just simplify what I can. 4 squared is 16, x to the 4th, y to the 6th. Well, 16 can go down to 4 and 4, 2 and 2, 2 and 2, and I have 4, if I can write something that people can actually see. There's 4 x's, and then there's 6 y's. Okay, so since it is a cube root, I need groups of 3 to pull numbers and variables out. I do have 3 2's, so I can pull out a 2. I do have 3 x's, so I can pull out an x, and I have 2 y's, so I can becomes a y squared. This is a cube root. I have an extra 2 and an extra x, so that would be my final answer. These are all examples of ones that would be easier to solve changing it to radical form. Again, there's no negatives anywhere in there. My fraction, the only fraction that I have is on the outside. Those are the ones that are easier to go through and solve using radical form. Alright, so let's look at some that it's going to be easier to go through and keep them into rational exponent or exponential form. So if you need anything from the screen, go ahead and get it. I'm going to clear it off. Alright, so the general rule, like I was saying, if you have any negatives in your problem, or you have any fractions inside your parentheses, that's when it's going to be easier to use your exponent rules to solve. So, for example, let's do an 8x squared. We'll do a y to the 1/3 the 2/3. Alright, now while this example doesn't have any negatives to it, I do have a fractional exponent inside my parentheses. Now, don't write this part down, but what would end up happening is if I were to change this to radical form, I would have ended up having another cube root inside a cube root, and that is not something that we really want to go through and solve. So that's what I'm saying. If you have a fraction inside the parentheses, you're going to have a radical inside a radical, which is probably not going to be easier to solve. It's probably going to be easier to use your exponent rules. So using our exponent rules, we're basically going to take this outer exponent and multiply it to each of the exponents inside here. Okay? So much like the problems that we did yesterday. So unlike the ones we looked at a little while ago, those were ones where, I changed the 3 at the bottom right here became a cube root, and then this top number changed all the exponents inside. But we're keeping it as a fraction, and we're just going to multiply 2/3 to each of our exponents. Do remember that 8 does have an exponent of 1, so this is going to become an 8 to the 2/3. Oops, sorry. Comes an x. Now I got to multiply 2 times 2/3, which is 4/3. And then I have to do 1/3 times 2/3, which is 2/9. And if you don't remember how to multiply fractions, you just multiply 2 top numbers together, 2 bottom numbers together. Or if you find it easier, you can type them in your calculator and multiply those up. Now, with these, I know it seems a little weird leaving these in proper fractions, or at least for that x value, but honestly in Math 2, they're just going to leave them that way. Usually the only thing that you're going to see that's going to simplify is going to be this front number right here. And you had one like that on your homework yesterday. And for a lot of you that got stuck on that problem, I just said, just go ahead and plug it in and get your answer. I didn't get a chance to show you by hand. So I'm going to show you real quick how you can do that by hand. 8 to the 2/3. I don't care if you use a calculator or if you do it by hand. It's up to you. Alright, 8 to the 2/3. What you end up doing is you keep that exponent of 2/3, you just change the 8. 8 is the same thing as the 2 to the 3rd. So if I multiply these two exponents together, I get 2 to the 6/3, which is 2 to the 2nd, which comes out to a 4. So that 8 to the 2/3 becomes a 4, x to the 4/3, and y to the 2/9. And that, honestly, is the way that they're going to look on the Math 2 exam. So a lot of these are probably going to be easier solving in exponent rules than it is in radical, especially if you have any fractions or negative exponents. So if you need anything from that example, go ahead and get it. I'm going to clear the screen off, and we're going to do a few more examples. Alright, so let's try one that's starting to get some negatives going on. This is a little more of what they want you to be able to do in Math 2. So let's say an x, or 4x to the 1/2, y to the -2, and we'll do an exponent that's negative this time, so -1/2. Alright, so in this problem, I've got a lot of negatives, so automatically radical form is going to be out of the question. It's going to be easier to use our exponent rules. So even though I do have some negatives, leave them alone for now and just do your exponent rules. 4 has an exponent of 1, and we're going to go through and we're going to multiply -1/2 to each of these exponents. Okay. So what I'm going to end up getting is I'm going to end up getting a 4. 1 times -1/2 is -1/2. And with my x's, 1/2 times -1/2 is going to be a -1/4. And with my y value, -2 times -1/2 is going to be 2/2, which is a 1. Now this is where we want to start moving those negative exponents. So I see negative exponents. I'm going to go ahead and draw my fraction bar because I know I'm going to put some stuff on the top and some stuff on the bottom. This one has a negative exponent, so it's going to move to the bottom and get rid of the negative. This one has a negative exponent, it's going to move to the bottom, get rid of the negative. This one does not, so it's going to stay at the top. And usually at that point, the only thing that's going to simplify is that number right there. So everything else is going to stay the same for ours. This is going to stay a y, this is going to stay an x to the 1/4. I just need to simplify 4 to the 1/2. So 4 to the 1/2, you can either simplify it out by hand. 4 to the 1/2 is the square root of 4, and the square root of 4 is 2. So this would be our final answer to that. That's probably a decent size for math too, using your exponent rules and just simplifying. And it is okay to have some of those as fractional exponents in your final answer. Alright, so let's go through. If you need anything from this one, go ahead and get it. We're going to look at a couple more examples. Alright, so let's say, I'm going to try this one. 4 x to the negative 4, y to the negative 1/2, and we're going to try to a 3/2. Okay, so a lot of fractions too. Again, I see some negatives, I see some fractional exponents. Definitely not going to want to try to do radical form. So, I'm going to end up going through and multiplying this exponent of 3/2 to each of my other exponents. Oops. Okay, so if I go through and do that, remember that 4 has an exponent of 1, so this is going to become a 4. 1 times 3 over 2 is 3 over 2. X, negative 4 times 3 over 2 is a negative 12 over 2, which is a negative 6. And for my y value, negative 1/2 times 3/2 is a negative 3 over 4. Now, I want to start moving stuff around. I see some negative exponents. I'm going to go ahead and draw my fraction bar because I know stuff's going to move around. This one does not have a fractional or a negative exponent, so it's going to stay at the top. This one does, move to the bottom, get rid of the negative, and so does this one. So it's going to move to the bottom and get rid of the negative. And kind of like we talked about in that last problem, at that point, the only thing that's ever going to simplify is this number. You can simplify that number out by hand, or you can just type it in your calculator. Actually, that's the same number from your homework yesterday too. So if you were to go through and do this by hand, that 4 to the 3/2 would become a 2 squared to the 3 over 2, because 2 squared is the same thing as 4. And that becomes a 2 times 3, multiplying those top numbers, so I get 6 over 2, which gives me a 2 to the 3rd, which will give me an 8. So this one becomes an 8 over x to the 6th, y to the 3/4. Okay, and that would be our final answer in Math 2. Okay, let's try, okay, let's change it up and look at a couple. We'll look at 2 more examples. That should prepare you enough for your homework. So if you need anything from the screen, go ahead and get it. I'm going to clear it off. Alright, so another type of problem that's kind of common in Math 2 is you might see something like x to the 1/2, y to the negative 5/2, x to the negative 1/3, and a y to the 1/2. Okay, so using our exponent rules from yesterday when we discussed these, if you have 2 things with the same base, which we do right there, these 2 have the same base of x, you basically want to subtract the exponents. Okay, so in this problem, as we go through and solve, we have our base of x, and we have to subtract those exponents. So we're going to subtract 1/2 minus negative 1/3. Okay. So 1/2 minus negative 1/3 is a 5/6. So that becomes x to the 5/6. You could have moved that 1/3 to the top if you wanted to, and then added 1/2 and 1/3. It'd become a 5/6. And we do the same thing with our y value. So we're going to you can subtract your exponents the way they are now, or you could have moved that 5/2 to the bottom and then added them together. But either or, negative 5/2 minus 1/2 is a negative 6 over 2, which comes out to a negative 3. Alright, so I have a negative exponent, so for my final answer, x to the 5/6 will stay at the top. The y to the negative 3, it'll move to the bottom and get rid of the negative. So that would be our final answer to it. And these are common in math too. Just subtract your exponents, and then, or at least that's usually what I'll do. I'll subtract my exponents first. And then if I end up with anything with negative exponents, I move it to the bottom and get rid of the negative. Alright, we'll look at one more question, so if you need anything from this, pause the video. Alright, so last one of the day, we'll look at a x to the negative 2, y to the 1/4, x to the negative 3, and we'll do just a regular y at the bottom, all of that raised to an exponent of 4. Alright, so with something like this, since we have a lot of stuff in the parentheses, this exponent of 4 has to multiply to these two exponents up here and these two down here. And remember that y value technically has an exponent of 1. So, this is going to become x to the negative 8th, 1/4 times 4, which will give me a y to the 1st. X down here, negative 3 times 4 is negative 12, and 1 times 4 gives me a 4. So now at that point, again, I could just subtract my exponents the way that they are, or I could move the negative 8 to the bottom, make it positive, move the negative 12 to the top, make it positive. But either or, this will become an x to the 4th. If I subtract my exponents from y, 1 minus 4 gives me negative 3. Again, I have a negative exponent, so positive exponents stay at the top, negative exponents move to the bottom, and when we do so, we get rid of the negative. So that kind of just shows you an example of all the different types that are in your homework, and actually a few additional ones. So I do want to, if you are in the regular class, if you're in my first period, you can stop the video at this point. If you're in my honors class in second period, I'm going to show you a couple of additional, a little more challenging problems to be able to look at. So I'm going to clear the screen. So for honors class, you might start getting some crazy looking things. So let's say I had, I don't know, let's say a square root of 3 to a, underneath this cube root, and also underneath the 4th root. And let's say we're going to raise all that to the 8th power. Now, that is a radical within a radical within a radical, which looks really complicated. But if you change something like this into exponent rules, it's actually not too bad to solve. So we're going to look at this first part right here, the square root of 3. If we change that into exponential form, that's a 3 to the 1/2. Okay. Now, that is within this one right here, the cube root. Well, a cube root of something is just like 1/3ing it. And that is within a 4th root. So that's just like doing something to a 4th. And then we also have all of that into the 8th power. So all we really have to do is simplify our exponents to this. So 1/2 times 1/3 times 1/4 times 8 actually gives us, believe it or not, a 1/3. So the answer to this one is a cube root of 3. Okay. So keep in mind, I'm just giving you something a little more challenging. When you first see that, it's a little crazy looking, but you can change each of those into fractional exponents and then use your exponent rules, and it's not too bad. And for honors class, I think that's all I'm going to show you. Just wanted to show you what you could do with a radical within a radical within a radical.